discussing in our last session that was related to data warehousing and data mining. From this pictorial diagram, we can recall what we have discussed in our last session, and we will be starting or we will be moving further from the data part, which includes the load manager. Data flows into the data warehouse through the load manager. The data is mostly extracted from the operational databases and the other internal sources like archived historical data and supplemented by data imported from external sources. For example, a gas pipeline operator in Western countries like UK, US, Canada, etc., may use weather forecast data from the country's meteorological office on regular basis to determine demand for gas, the main source of energy used for heating homes and offices in various areas of these countries. Types of data from external source that may be included in data warehouse are financial indicators and statistics of the industry, market share, data of competitors, demographic data, weather data, credit worthiness data, leadership, viewer data, survey data for the advertising media, especially commission surveys and so on. External data is usually obtained from commercial database services or government agencies like Meteorological Office, Celsius Agency, Industry Association, stock exchanges, local government, and statistical services. The load manager primarily performs what is termed as extract transform load, that is ETL operation, which includes data extraction, data transformation, and data loading. Data extraction, this function has to deal with numerous data sources. Appropriate techniques have to be employed for each data source. Source data may be from different sources, machines in diverse data formats. Parts of the source data may be in relational database system. Data extraction can become quite a complex operation at times. Various tools are available on the market for data extraction. After extraction, the data needs to be kept somewhere for further preparation. Sometimes the extraction function is performed in the legacy platform itself if that approach suits the design framework. In the separate environment, the data source may be extracted into a group of flat files or an intermediate relational database or a combination of both. The physical environment is called the data staging area. Data transformation. In every system implementation, data conversion is an important function. For example, when implementing an operational system, such as magazine subscription application, the database has to be initially populated with data from the existing system records. Data for a data warehouse comes from many disparate sources. If data extraction for a data warehouse poses great challenges, data transformation present even greater challenges. Another factor in the data warehouse is that the data feed is not just an initial one-time feed. A number of individual tasks are performed as part of data transformation. First, the data is extracted from each source, is cleaned. Cleaning may be correction of misspellings, etc. The end result of the data transformation function is a collection of integrated data that is cleaned, standardized, and summarized. Now, the data is ready to be loaded for population, the data warehouse. Data loading, two distinct groups of tasks from the data loading functions. After completion of the design and construction of the data warehouse, when it goes live for the first time, the initial loading is done. The initial load moves large volumes of data, which may be substantial amount of time, but it is a one-time effort. Data query. query manager provides an interface between the data warehouse and its users. It performs tasks like directing the queries of the appropriate tables, generating views on an ad hoc basis if required, monitoring the effectiveness of indices and summary data, and query scheduling. Data warehouse design considerations. The key consideration involved in the design of a data warehouse are time span, granularity, dimensionality, accelerations, and partition. Time span. In short, data warehouse data tends to be historic in nature. This is the data warehouse data represents company transactions up to a given point in time. Yesterday, last week, last month, and the like. The time period for which the data is held in the data warehouse is determined by the data analysis requirements of the user of the data warehouse. These needs in the term arise from the changes in the business environment that a particular organization needs to monitor in its efforts to stay ahead of its competitors. Granularity, according to Imon, the single most important design aspect of a data warehouse is the decision on granularity. It refers to the level of detail or summarization available in units of data in the data warehouse. The more details there is, the lower the level of granularity. The less details there is higher level of granularity. Dimensionality. This is probably the most distinguishing characteristics of a data warehouse. From the data analysis point of view, data is always related in many different ways. For example, when we analyze product sales by a customer during a given time span, we are likely to ask how many widgets of type X were sold to customer Y during the last 6 months. Aggregations. We have seen how analysis queries directed of data warehouse involves dimensions. Another very common type of query directed at data warehouse involves sums of value along the different dimensions. To avoid excessive processing load on data warehouse arising from frequently asked queries of this type, it is often decided at design time to store some pre-calculated aggregations. Partitioning. One of the essence of data warehouse is flexible data storage, master and access. When data resides in large physical units, among other things, it cannot be indexed easily, sequentially scanned if needed, restructured easily, backed up conveniently, recovered easily, and can be monitored easily, and so on. Data warehouse schema. One of the key questions to be answered by the database designer is how can we design a database that allows unknown queries to be performed? This question encapsulates the differences between designing for a data warehouse and designing of an operational database and information system. In a data warehouse, one designs to support the business processes rather than specific query requirements. In general, the queries directed at the data warehouse tends to ask questions about some essential facts analyzed in different ways. For example, reporting on the average number of light bulbs sold per store over last month to avoid excessive processing load on data warehouse arising from frequently queries of this type. It is often decided at design time to store some pre-calculated aggregations. The top 10 most viewed TV programs from a TV channel or channels during the past week, top spending customers over the past quarter, customers having average credit card balance more than 50,000 during the last year. But these are some of the examples which are need to be answered. Each of these queries has one thing in common. They are all based on factual data. The content and presentation of the result may differ between examples, but the factual and transactional nature of the underlying data is the same. One of the major technical challenges within the design of a data warehouse is to structure a solution that will be effective for a reasonable period of time, at least for 3 to 5 years. This implies that the data should not have to be restructured when the business changes or the query profile change. This is an important point because in more traditional applications, it is not uncommon to restructure the underlying data in order to address query performances issues. Inherent advantage of factual transactions is that their content is unlikely to change, regardless of how it is analyzed. Also, the majority of the data volume of a data warehouse comes from the factual information. It is therefore possible to treat fact data as read-only data and the reference data used to interpret the fact data as data that is liable to change over time. The dimensional information represented by the reference data is often organized in the form of concept hierarchies that are used for analysis and designing data warehouse aggregations. What is metadata? Metadata in a data warehouse is similar to the data dictionary in the context of a database. It stores data about data in the data warehouse. What are the different types of metadata? Metadata in a data warehouse falls into three major categories. Number one, operational metadata. Number two, extraction and transformation metadata. And the third one is end user metadata. If we talk about operational metadata, data for the data warehouse comes from several operational systems of the enterprise. These sources system contains different data structures. The data element selected for the data warehouse has various field lengths and data types. Selecting data from different sources files and locating it into the data warehouse requires splitting of data, combining parts of records from different source files, and dealing with multiple coding schemes and field lengths. Extraction and transformation metadata. This contains data about the extraction of data from the source system, namely the extraction frequencies, extraction methods, and business rules for data extraction. And what about end user metadata? The end user metadata is the navigational map of the data warehouse. It enables the end user to find information from the data warehouse. The end user metadata allows the end user to use their own business terminology and look for information in those ways in which they normally think of the business. Metadata requirements. According to Iman, a new user approaching a data warehouse wants to know what tables, attributes, and keys does the warehouse contain? From where did each set of data come? What transformation logic was applied in loading the data? How was the data changed over time? What arises exist and how are they related to each other? What are the cross references between technical and business terms? How often does the data gets reloaded? What are the components of metadata? Warehouse metadata is not very different in kind from ordinary database metadata, although it is versioned in order to permit historical analysis. Prism gives the following breakdown of warehouse metadata in TechTop. metadata in the data warehouse. Mapping. The mapping information records how data from operational source is transformed on its way into warehouse. Typical components are identification of source fields, simple attribute to attribute mapping, attribute conversion, physical characteristics conversion, and encoding reference table convergence. Extract history. Whenever historical information is analyzed, meticulous update records have to be kept. The metadata history is a good place to start any time report because the analyst has to know when the rules change in order to apply the right rules to the right data. Data warehouse and the web. Professor Peter Drucker, the senior guru of master practice, has admonished IT executives to look outside their enterprises for information. He remarked that the single biggest challenge is to organize outside data because change occurs from the outside. He predicted that the obsession with the internal data would lead to being blindsided by external forces. The majority of data warehousing efforts results in an enterprise focusing inward. However, the enterprise should be keenly alert to its externalities. As market becomes turbulent, an enterprise must know more about its customers, suppliers, competitors, government agencies, and many other external factors. The change that takes place in the external environment ultimately gets reflected in the internal data and would be detected by the various data analysis tools discussed in the later sections. But by then, it may be too late for the enterprise. Proactive action is always better than reacting to external changes after the effect has felt. Reliability of web content. Many questions the reliability of web content as they should. However, few analyze the reliability issue to any depth. The web is a global bulletin board on which both the wise and the foolish have equal space. Acquiring contents from the web should not reflect positively or negatively on its quality. Think of web resources in terms of quality and coverage. In the figure towards the top are information resources of high quality, accuracy, currency, and validity. And the resources towards the right have wide coverage, that is scope, variety, and diversity. The interesting aspect of the web is that information resources occupy all quadrants. In the upper center, the commercial online database vendors traditionally have supplied business with high quality information about numerous topics. More to the left, the government databases have become tremendously useful in recent years. Earlier, public information was often available only by spending many hours of manual labor at libraries or government offices. And at the left, the corporate websites often contain vast amount of useful information in white papers, product demos, audios, videos, and press releases, eliminating the necessity to attend trade exhibits to learn the latest and the greatest in the marketplace. Finally, the doubtful quality free content occupies the lower half of the figure. Its value is not in the quality of any specific item, but it is constantly changing diversity. Then comes online analytical processing, that is OLAP. Earlier, we have discussed the need for building an enterprise data warehouse, followed by discussion on its structure and the ways and means of operating it with data. The data warehouse serves as the memory of the enterprise, but memory is of little use without intelligence. The tools that analyze data provides the intelligence. In this section, And the ones that follow, we discuss some of the tools available for assessing the data warehouse and transforming the data in it into information useful from the point of view of the business or business intelligence. The term online analytical processing, that is OLAP, was coined by E.F. Cott in 1993 to refer to a type of application that allows a user to interactively analyze data. OLAP is a method of analyzing data in a multi-dimensional format, often across multiple time periods, with an aim of uncovering the business information concealed within the data. OLAP enables business users to gain an insight into the business through interactive analysis of different views of business data that have been built up from the operational systems. OLAP can be defined as the process of converting raw data into business information through multi-dimensional analysis. This enables analysts to identify business strengths and weaknesses, business trends, and the underlying causes of these trends. It provides an insight into the business through the interactive analysis of different views of different business information that have been built up from raw operating data, which reflects the business users' understanding of the business. The OLAP application contains logic which includes multi-dimensional data selection, subsetting of data, retrieval of data via the metadata layers, and calculation formulas. Multidimensional OLAP, there are four major types of OLAP operations. Multidimensional OLAP, hybrid OLAP, desktop OLAP, and relational OLAP. In short, we will see what they are all about. Multidimensional OLAP is based on multidimensional data based architectures. Relational OLAP products are designed to operate directly on a data warehouse built on relational databases through a comprehensive metadata layer. Hybrid OLAP product primarily integrates specialized multidimensional data storage with relational database master technology. And the desktop style of OLAP allows users to perform limited analysis directly against data held within a relational or object oriented database while avoiding many of the problems that affect hybrid and relational OLAP styles. Data visualization. Business decision makers use data to identify opportunities, trends, and areas of concern in their respective businesses. Most data reaches the user in the form of tabular reports, which they find challenging to quickly and effectively absorb the information, spots patterns, identify aberrations, and see hidden relationships. Data visualization application renders large quantities of data in the form of basic charts, graphical indicators, scorecards, dashboards, advanced visualizations, animations, and virtual reality environment. By formatting the fundamental aspect of data analysis, they help information users identify trends and patterns in data that are often not apparent in traditional tabular representation. Managers have found these applications more effective for viewing business activity as take glance. Data visualization involves graphical image generation by software, where the content of the image is determined by reading digital data. The data is usually numeric, but some softwares can visualize concepts drawing from text documents. The software arranges geometric shapes such as point, lines, circles, and rectangles to create an interpretation of the data it reads. Attributes such as proximity, size, and color expresses relationship between the geometric shapes. Three strong trends have shaped the direction of data visualization software for business users over the last years. That is chart type, level of user interaction with visualization, size and complexity of the data, structured represented by visualization. Chart type, most data visualization depends on the standard chart type, whether a rudimentary pie chart or an advanced scatter plot. The list of charts types supported by software has lengthened considerably in recent times. Level of user interaction with visualization. A few years ago, most visualization was static chart for viewing only. At the cutting edge of data visualization today, dynamic chart types are themselves the user interface, where the user manipulates a visualization directly and interactively to discover new views of information online. Size and complexity of data structures represented by visualization. A rudimentary pie or a bar chart visualizes a simple series of numeric data points, never advanced chart types. However, visualize thousands of data points or complex data structures such as neural nets. Data visualization has long been in use in softwares for the study of mathematical, statistical, geographic, and spatial data. Some data visualization softwares for business users has borrowed chart types originally designed for scientific uses, such as scatter plots and constellation graphs. What is good visualization? Effective ease of interpretation should be accurate, sufficient for correct quantitative evaluation. Aesthetics must not offend viewers' senses and adaptable, can just to serve multiple needs. Human perception capabilities and the fact that all displays needs to be mapped in a two-dimensional flat computer screen or sheets of paper when printed imposes many limitations. For example, according to one researcher, inaccuracy of human perception increases in the following order when the respective techniques are used for visualization. Positioning along a common scale, positioning along identical non-aligned scale, length, angle, slope, area, volume, hues, saturation, intensity, these are the areas. The techniques commonly used to overcome the limitation of two-dimensional displays and size restrictions are scaling and offset to fit in range, derived values that is residential locks to emphasize changes, projection and other combinations to compress information, random jiggling to separate overlaps, multiple views to handle hidden relations, high dimensions, effective grid, keys and labels to aid understanding. Now, data mining. According to Barry and Linoff, data mining is the exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful patterns and rules. This definition justify raises the question, how does data mining differ from OLAP? OLAP is undoubtedly a semi-automatic means of analyzing data, but the main difference lies in the quantities of data that can be handled. Why is data mining being put to use in more and more businesses? Here are some basic reasons. In today's world, an organization generates more information in a week than most people can read in a lifetime. It is humanly impossible to study, decipher, and interpret all the data to find useful patterns. A data warehouse pulls all the data after proper transformation and cleansing into well organized data structure. In recent times, many data mining tools suitable for a wide range of applications have appeared in the market. The tools and products are now mature enough to be used in businesses. Data mining needs substantial computing power. Parallel hardware, databases, and other powerful components are available and are becoming very affordable. Organizations are placing enormous emphasis on building sound customer relationships, and for good reasons. Companies want to know how they can sell more to existing customers. Organizations are interested in determining which of their customers will prove to be a long term value for them. Companies need to discover any existing natural classifications, among other things, so that they reach each such class may be properly targeted with products and services. What are the different data mining techniques? Data mining covers a broad range of techniques. Each technique has been heavily researched in recent years, and several mature and efficient algorithms have evolved for each of them. The main techniques are cluster detection, decision trees, memory based reasoning, link analysis, induction, association rule discovery, outer detection and analysis, neural network, and genetic algorithms and sequential pattern discovery. Now comes data mining applications. Data mining technology encompasses a rich collection of proven techniques that cover a wide range of applications in both the commercial and non-commercial realms. In some cases, multiple techniques are used back to back to greater advantage. Non-commercial use of data mining is strong and pervasive in the research area. In oil exploration and research, data mining techniques discover locations suitable for drilling based on potential minerals and oil deposits. Pattern history and matching techniques have military application in assisting to identify targets. Medical research is a field ripe for data mining. The technology helps researchers with discoveries of correlations between diseases and patient characteristics. Crime investigation. Agencies use the technology to connect criminal profile to crimes. In astronomy and cosmology, data mining helps predict cosmetic events. Consider the following list of few major applications of data mining in the business area. Customer segmentation. This is one of the most widespread applications. Businesses use data mining to understand their customers. Risk master. Insurance companies and mortgage businesses use data mining to uncover risk associated with potential customers. Market basket analysis. This is very useful application for the retail industry. Association rule algorithm uncovers affinities between products that are bought together. Fraud detection. Credit card companies use data mining to discover abnormal spending patterns of their customers. Such patterns can expose fraudulent use of the card. Delinquency tracking. Loan companies use the technology to track customers who are likely to default on repayments. Demand prediction. Retail and other businesses use data mining to match demand and supply trends to forecast for specific products. What are the benefits of data mining? Without data mining, useful knowledge lying buried in the mountains of data in many organizations which would never be discovered, and the benefits from using the discovered patterns and relationships would not be realized. With the enormous utility of data mining, the following list enumerates some real world situations. A mail order company improves direct mail promotions to prospect through non targeted campaigns. A department store hikes the sale in specialty department by anticipating sudden surge in demand. A manufacturer of diesel engine increases sales by forecasting sales of engines based on the patterns discovered from historical data of truck registrations. A national health insurance provider saves large amount of money by detecting fraudulent claims. Now, we move on to Unit 14, which is related to artificial intelligence applications in decision making. First of all, the thing is that what is meant by artificial intelligence. The advent of artificial intelligence is fact took place when the first modern computer emerged in the middle of last century. Frankly, when a computer does it, what it stimulates collective thinking of several humans to process high volumes of data at a high speed and accuracy. The growth in capabilities actually means that computers are becoming more and more competent of delivering more than the human abilities. These enhanced competencies are then used to deliver more power in business activities. The goal of artificial intelligence scientists have always been to develop a thinking machine that solves problems in a way that would be considered intelligent if done by a human. This forms the basis of our definition to artificial intelligence. The term AI was first introduced by McCarthy. Intelligence is the computational part of the ability to achieve goals in the world. Artificial intelligence thus can be defined as a field that focuses on building techniques to enable computer systems to perform activities that are quick and are above human intelligence. The need of artificial intelligence has arisen because initially a need was felt to solve tiny and trivial problems. To counter this, it was felt necessary to use skillfully coded real world knowledge and rules into a computer, which in turn simplifies the problem solving efforts. Artificial intelligence is not to replace humans, it augments our abilities and makes us better at what we do. Artificial intelligence enhances the speed, precision, and effectiveness of human efforts in financial institutions. All artificial intelligence techniques can be used to identify which transactions are likely to be fraudulent, adopt fast and accurate credit scoring, as well as to automate manually intense data master tasks. Artificial intelligence is being used today in industries, hospitals and healthcare, education, agriculture, legal, R&D, banking, and almost everywhere. What are the goals of artificial intelligence? Intelligence works on the following goals. Number one, emulate humans. From the very basic definition of artificial intelligence, it has become clear that artificial intelligence main goal is to identify solvable and out of the ordinary information processing problems and solve them. Number two is develop expert systems on real life problems. Artificial intelligence has real life problems in the world as its pivot. Artificial intelligence goal is to develop expert systems that stimulate the real world problems and solve them automatically. Third one is solve problems that require intelligence, be it a program that plays chess or a system that has all intelligence of a dictionary. The primary aim of artificial intelligence has always remained to study and solve that are knowledge intensive and require a high degree of intelligence. Number fourth is creating some system that can exhibit intelligent behavior, learning how things by itself, demonstrate, explain, and can advise to its users. And the fifth one is enhance interaction. Artificial intelligence works for enhancing human computer, and computer computer interaction. Computers have now accepting more and more very use interface for input and output processes like voice, vision, and virtual reality, etc. We can find a lot of varied applications of artificial intelligence. It has been applied in game playing, automated grammar checking, speech recognition, vision systems, expert systems like weather forecast diagnostic system, financial decision making, and classification system, computer stimulated natural processes, mathematical theorem proving, natural language understanding, and many more. Now let us see some of the examples of these applications. Artificial intelligence in automated grammar checking. You must have used a word processor and used its spelling and grammar checking features. While spelling checker module works well, there is a lot that has been done for grammar checking module. Artificial intelligence in speech recognition. We have seen the softwares that types the word as one speaks. These are called phonetic typewriters. Speech understanding has been found good confirmation values in the recent time. Artificial intelligence is an expert system. It has played significant role in creation of expert system for weather forecasting, diagnostic systems such as medical diagnosis systems, pathology diagnosis systems, and customer assistance systems, etc. Financial decision making systems like fraud detection system used in credit card companies are again a part of this expert system. In mathematical theorem proving, there had been many attempts of providing mathematical theorem with the help of artificial intelligence tools. Interface methods are used to prove new technologies. Artificial intelligence in scheduling and planning. Automatic scheduling for manufacturer and rerouting scheduler for airlines, etc. Operation Desert Storm use these systems for planning logistics for people and supplies. Artificial intelligence in healthcare. Healthcare industries are applying artificial intelligence to make a better and faster diagnosis than humans. Artificial intelligence can help doctors with diagnosis and can inform when patients are worsening so that medical help can reach to the patient before hospitalization. Artificial intelligence in social media. Social media sites such as Facebook, Twitter, and Snapchat contain millions of user profiles, which need to be stored and managed in a very efficient way. Artificial intelligence can organize and manage massive amount of data, can analyze lots of data to identify the latest trends, hashtag, and requirement of different users. Artificial intelligence in automotive industry. Some automotive industries are using artificial intelligence to provide virtual assistance to their user for better performances, such as Tesla has been introduced to Tesla Bot, an intelligent virtual assistant. Various industries are currently working for developing self driven cars which can make your journey more safe and secure. Artificial intelligence for robots. Artificial intelligence has a remarkable role in robotics. Usually, general robots are programmed such that they can perform some repetitive tasks. But with the help of artificial intelligence, we can create intelligent robots that can perform tasks with their own experience without pre programmed. And artificial intelligence in e commerce. It is providing a competitive edge to the e commerce industry and it is becoming more demanding in the e commerce business. It is helping shoppers to discover associated products with recommended size, color, or even brands. Now comes building artificial intelligence. While building artificial intelligence in an organization, one has to think about many factors such as observation, reasoning, and action. You might have seen different softwares for medical diagnosis. For example, homeopathic software contains a set of symptoms and test results that has been obtained and inputted to the system manually. Whenever a patient inputs his systems, then the diagnosis system matches it with the record ones to give a diagnosis. The key to artificial intelligence approach is intelligent search and making. Expert systems. The most noteworthy development in the field of artificial intelligence is the advent of expert or knowledge based systems. Joint efforts by human experts yielded systems that can diagnose diseases, fly planes, drive vehicles, and configure computer systems at performance level that can exceed the best human expertise. Question thus arises that what are expert systems? To put it more simply, expert systems are computer programs that use knowledge to solve problems competently and successfully. They are similar to human experts in the sense they also use logic and heuristics to solve problems. And they also make errors and they also learn from their errors. An expert is a person who, because of training and experience, is able to do things the rest of cannot. Experts are not only proficient but also smooth and efficient in actions they take. Underlying the behavior of experts in body of operative knowledge, we can we have termed expertise. Now comes emerging trends in information technology. Competitiveness of ICT. User of information and communication technologies have proved as the tool for increasing efficiency level in all spheres of operation. No organization can stand today without using ICT tools. The dramatic and continuing liberalization of world trade is indeed a central feature in global economy, and the spread of ICT and goods derived using ICTs have been rapid with an accompanying emphasis on the issues of competitiveness. An enterprise is said to be competitive if it can cut its share in international and domestic markets from its rivals. The term competitiveness can also be used in the context of national economy to judge whether the nation is moving ahead in building market shares in business sectors that promotes economic growth, employment, and other measures of social development. The use of production of ICT is not itself a principal determinant of social welfare measures like growth or employment, but it does play an important role in the ability of nations to participate in economic activities where growth and employment prospects are more favorable than would be available otherwise. Every major change in global economic activities has witnessed a complete transformation of industrial growth patterns involving different processes, practices, and materials yielding explicit gains. In industrial nations, most of these gains have been realized by the first half of the 20th century, owing it to rapid industrialization. During the second half of the 20th century, the industrial growth of developing nations may have been constrained by the existence of productive capacity of already industrialized nations. The ICT provides an opportunity for addressing manufacturing productivity advances in developing nations, which would allow a substantial expansion of industrial output. Because ICT are often labor saving, a large increase in output is necessary to raise the derived demand for labor through productivity improvement. Otherwise, the impact of ICTs may be to reduce labor inputs, an undesirable and alarming outcome for developing nations if there are more sufficient employment alternatives. Technological improvement in semiconductor technology, as measured by the cost and speed of performing narrowly defined functions, has advanced at rates that were unprecedented for other manufacturing technologies, such as power generation using fossil fuels or improvements in machine operating speeds through improvement in mechanical technology. Productivity gains from the use of information technologies involve improved control, smoother integration of production processes, and better control in the acquisition of inputs and the disposition of outputs. Communication technologies plays an important role, particularly in coordination of functions such as conveying timely information about inventories and scheduling throughout a distribution system. The productivity trends from ICT are generally realized through cost reduction in material inputs, labor, and capital. In addition, ICTs usually make it possible to produce more or highly quality with the same level of inputs, resulting in productivity advances that are independent of changes in input use. Growth in the use of ICT in manufacturing appears to involve greater flexibility and changeover speed, as well as shortened and accelerated flows of material for processing, work in process, and finished good inventories. These changes suggest a transformation in methods of organizing production systems from traditional model of mass production. This is important for all the industries and sectors like manufacturing, education, health, pharmaceuticals, hospital, hospitality, governments, and so on. The use of ICT has made it possible to expand other economic activities, conventionally referred to as service sector. The contribution of ICT in the service area are apparent that the fact that ICT are a major component in the predominant form of physical capital that service industry employ. For development nations, an increasing share of output in service is consistent with increasing investment in human capital or the dispersal of industrial activities domestically and internationally to reduce localized environmental problems. The growth of service provides domestic growth opportunities that can absorb labor displayed by productivity improvement in agriculture and industry that are less challenged by imports from developed or other developing nations. Developing and implementing the organizational changes would permit ICT used to have the same productivity impact in services as previous organizational changes had in manufacturing sector. For example, in financial services, where the ICT do support economies of scale in transactions processing, they also permit the creation of many new services. ICT intensive retailing activities, the system that manufacturers employ, must increasingly be compatible with the emerging new industrial models based on more intense ICT use. Example of these development includes the growing emphasis on international quality standards with high level of information content, the specification of product design using computer aided design and manufacturing, and the coordination of product delivery, such as just in time and sales driven production using high level of ICT. Effective use of ICT requires knowledge from the range of disciplines and the solution of difficult problems of synthesizing technological knowledge and managerial know-how. The absence of well-established models for effectively achieving this synthesis suggestion that the creation of substantial variety of knowledge, creating and using capabilities will improve the likelihood of adaptive success in realizing the potential from ICT. Convergence of IT and consumer electronics, that is emerging trends. Information is key to progress in decision making. It is so vital that it has created information age. The decision could be by a person or it could be automated by creating knowledge base from big data. Seeing the trend in the growth of electronic components used in computers, Gordon E. Murray gave a prediction way back in 1965 that the number of transistors per silicon chip doubles each year. This is known as Murray's law. In all the computers and smart devices, silicon chips are used. Innovation and further development have resulted in bringing down the size of the actual product. The concept of large scale integration LSI and further very large scale integration VLSI came into existence, because of which we find today small computing devices and IT tools with tremendous capabilities. The world has been seeing the convergence of technology. It was to continue to be an important trend and the key to growth for various sectors within the broader technology arena. Use of internet has penetrated in all the sectors. Automation with Internet of Things, that is IoT, can be seen with tremendous applications. Innovations are more rapidly seen in home networking, home appliance, games, Bluetooth devices, digital imaging, digital entertainment platforms, wireless technology, and digital radio receivers. One major aspect related to the above innovative technology is to develop emerging trends in IT, seamless wireless connections between small multifunctional devices in the home. The signal processing technology is playing tremendous role for digital audio, video, cells, phones, machine learning, broadband and wireless communication. Data science has become a separate discipline for mining, analyzing, and decision making. The expansion of broadband and high speed wireless networks have proved to be a key factor in the present and seems to continue in future proliferation of IT products to be used by common people in daily life. Fiber connectivity at home. with internet application like ITV clubbed with Bluetooth devices are providing endless services. Most of the advances in this direction will lead to developments in customer electronic products, in which convergence of different technologies and applications will come up as natural process. The consumer electronics industry, in short, is entering a new era based on the promises of utilizing broadband and wireless technologies to promote the more widespread use of electronic devices. Advanced in microelectronics further enhances the potential for consumer electronic devices to proliferate and be utilized well beyond what is the market today. With this, we will end today's session and all the best.